Welcome everyone. Today we are going to demystify one of the most fascinating and honestly one of the most misunderstood ideas in artificial intelligence: emergent decision making. Specifically, we are asking, how does AI arrive at decisions it was never explicitly taught to make? By the end of this presentation, you will understand exactly how a machine can invent a solution to a problem its own creators never anticipated. And we will see this play out through two real world stories, one in the sky and one inside the human eye. So, what's an emergent decision? Let's start with a definition stripped of the jargons. An emergent decision happens when an AI system solves a brand new problem or takes an action that no one explicitly coded it to perform. Think of it like a chef who has mastered dozens of techniques and ingredients, and given that the chef an unfamiliar set of leftovers and they won't freeze up, they will improvise a dish nobody wrote a recipe for, drawing on everything they already know. That's exactly what's happening inside the AI. And I want to underline this key point. It is not magic. The system is not thinking the way human does. Actually, AI is creatively recombining the patterns from its training to fit a situation it has never seen before. You may say that it's a mathematical solution of deciding from all permutations and combinations of possibilities with a relevant score, and finally select something which has got a high score so that becomes the possibility chosen by the AI system. So, to really appreciate how special this is, let's contrast three very different kinds of machine behavior. The programmed behavior follows rigid human written rules. If the battery drops below 10%, land immediately. But a learned behavior recognizes patterns it has encountered many times in its training data. This image looks like a cat, for example. But emergent behavior is different in kind, not just degree. It invents a brand new response to something it has never encountered by combining the knowledge in an original way. For example, follow the river through which we came. Nobody told me to do so, but it is the safest option. And the third category is where the things are getting genuinely interesting. So, how does this actually unfold step by step? There is a reliable four-stage pattern. First is the routine operation. The AI is simply doing its normal job. Second, an unexpected situation arises, something breaks the plan, a scenario nobody coded for. Third, and this is the heart of it, the emergent decision itself, where the AI forms brand new logic on the spot. And finally, the safe resolution, where it acts on that new plan and the problem gets solved. Notice I have highlighted the stage 3 in orange color because that's the true moment of emergence. The AI is not flipping through a rule book here. There is no if and else here. is running rapid internal simulations, hundreds of possibilities, and choosing whichever option best satisfies its deeper trained goals, for example, like safety or accuracy, etc. Right? So, the storm blind delivery drone. We are going to take an example. Let's ground this in a concrete story. Picture a delivery drone is carrying medical supplies to a rural hospital guided by GPS, the global positioning system, the satellite network that tells it exactly where it is at every moment. Mid-flight, a sudden storm knocks out of the local cell towers. In an instant, the drone loses both its GPS signal and its connection to central control. This is a situation its engineers never specifically planned for and never trained. And here is the question that matters. With no GPS and no ground control, what should the drone do next? There is, quite literally, no line of code that answers this exact question. So how the drone will think or thinks through this crisis? What happens inside the machine in that moment of crisis? Three things in rapid succession. First, it senses the world, the cameras, the light detection and wrangling a laser-based distance sensor, plus wind and battery sensors keep feeding it live data without even GPS. And second, it sets a new goal. Instead of flying to coordinate X, the objective becomes stabilize and find recognizable landmarks. The step 3. It imagines the options, running hundreds of simulated futures every single second. It considers hovering in place, but predicts the battery will run out and it will crash. It considers landing immediately, but predicts the payload will be lost in the dense forest. And it considers following the river it just crossed, predicting the best odds of both safety and signal recovery. Note that these are all not guesses. They are calculated predictions weighted against each other in real time. From the possibilities and combinations of the training data. Nobody programmed to do this, but from the patterns, the AI is creating the simulated possibilities and then gives a high score where safety is important, signal recovery is important, and selects that one. So, why is it emergent? The drone commits its choice, follow the river, it changes the direction, and using nothing but its onboard cameras, it visibly tracks the river's contours below, no GPS required eventually. It spots a water tower outside the storm's reach, reconnects to a distant cell power, and recalculates a fresh route to the hospital. Look at that. And here is why this qualifies as truly emergent. No programmer ever wrote the instruction, if GPS fails here, follow the nearest river. That rule simply does not exist in the code. Instead, the AI combined its broad understanding of physics, geometry, and safety and mathematically combined it on the spot to invent a solution unique to that exact moment. Well, let's shift the domains entirely now for another example. From the sky, now we go to human body. Because emergent decisions are not limited to robotics. So consider this example. The picture an eye clinic using an AI tool to scan retinal photographs, images of the back of the eye, screening for diabetic retinopathy, which is eye damage caused by diabetics. This AI was trained on millions of such scans, each cross-referenced with the patient's full electronic health record. During one entirely routine scan of a patient showing no cardiac symptoms whatsoever, the AI does something nobody expected. It flags a high risk for a heart attack. Nobody asked it to look for that, so the question becomes, how could a photograph of an eye reveal anything at all about the heart or heart attack? No clinical rulebook connects the two. Here is how the connection was made. First, the AI fuses the data sources. It reads the eye photo as an enormous grid of pixel values, combines it with the patient's age and blood pressure, processing far more variables at once than any human physician or doctor could. Step 2, it sees beyond human sight. Its neural network, a pattern recognition model loosely inspired by the brain, detects microscopic changes in blood vessel thickness that the human eye simply cannot perceive. And third, it connects two entirely separate medical fields, matching this eye pattern against historical data from patients who later suffered strokes or heart attacks, linking ophthalmology and cardiology for the very first time. The result? An 87% statistical probability that this particular patient would suffer a cardiac event within the next 6 months, calculated purely from the subtle patterns hidden in a photograph of that eye. So a life is saved because of this emergent decision making by the AI. The AI issued an alert to the clinician. High risk cardiovascular profile, recommend immediate electrocardiogram or EKG, a test that records the heart's rhythm, and cardiology referral. The surprised physician ordered a cardiac stress test and an ultrasound of the neck arteries, and the results, a 90% blockage in a major coronary artery. A routine stent procedure followed and a heart attack was prevented. Why is this emergent? Because no developer ever coded the rule. If retinal vessels thin by X percentage flag cardiac risk. Now, the AI discovered entirely on its own that the eye's tiny blood vessels mirror the health of the whole cardiovascular system, inventing a brand new diagnostic pathway that did not exist before it found it. So, the key takeaways, let's bring it all together. 1. The emergent decisions are not magic. It is the creativity behind the creation of AI, recombining the knowledge, considering the patterns, the permutations and combinations it already has. 2. The AI systems can solve situations their own creators never imagined or coded for. 3. Of course, the capability is powerful. AI needs careful safety checks before it acts. And 4. Both our stories show the same underlying phenomenon: AI generalizing far beyond the narrow task it was originally built to do. And for anyone who wants a quick reference of today's talk, from AI itself to GPS, LiDAR, EKG, and EHR, all these are here. This brings us to the end of our journey from the drone navigating a storm by starlight and instinct to an AI spotting a heart attack in the reflection of an eye. The common thread in both stories is this: intelligence, artificial or otherwise, becomes most remarkable not when it follows the instructions, but when it improvises wisely beyond them. Thank you so much for your time and attention today. And this presentation comes to you from the creators of Sigma Data and Sigmology, Passion Vibes Limited. Thank you.